My name is John Mao, and I lead the alliances team at VAST Data. I get to do a lot of cool things, working a lot of cool different partners across various different workloads. AI is obviously consuming a lot of our time these days. So I wanted to spend a few minutes. We have, I think, 85 minutes or so left. We're going to split the session in half. I'd like to reintroduce the company to some of you. It might be new. You guys may have not heard of VAST Data before. And also have some very, very exciting announcements we're making today with some very great partners of ours that wanted to present to you. You got kind of breaking news here, if you will. The second half of our session, my colleague Niloy will be taking you guys on a journey through what a real AI pipeline looks like. We've had the pleasure in the industry of working with a lot of leading AI companies, not just infrastructure companies, people doing the actual AI work. And we've learned a lot over the last 12 to 18 months, and we wanted to share some of that with you. I hope that will whet your technical appetite for sure in the second 45 minutes of today. So I know how this goes. I've seen a lot of these before. Feel free to chime in if you have a question. But otherwise, we're going to start at a high level and just kind of reintroduce the company. The company was founded back in 2015. I don't know how many of you have been following since back then, but we've seen quite great growth and success. The first few years of the company were really spent just building the product. If you fast forward just to last quarter, we raised our Series Z round at a valuation of $9.1 billion. And that valuation might seem pretty mind-blowing. It is to me. I never thought we'd get here at this point. But the reality is that valuation is based on our success and traction in the market from a business perspective. We've been growing tremendously fast year over year. We've been selling for about 4 years now in market, where we've been doubling and tripling our revenue on a software basis annually year over year. That's about $1 billion in software sales in the first 4 years, which I think by most analysts puts us in a pretty incredible category of companies. I think the thing that we're most proud of, however, is we've done that growth at that pace while maintaining a level of frugality, I guess you could say, meaning that we've been cash flow positive for, I think, almost the last 8 quarters, maybe more than that. Someone can fact check me later on the VAST team. And we've been racking up a whole bunch of different customers across the enterprise market. I'll talk about a few of these in just a second, as well as different cloud providers, which I'll definitely talk about here in a little bit. Now, what does that mean from a product perspective? A lot of money is good. What does it mean in terms of product? We've now deployed and are storing, I think, 10 exabytes of data globally across our install base. And that's really interesting. And the reason why we're here, and some people watching may not know this, is that while we do have heritage in kind of the enterprise storage space, the reality is ever since our first shipping product, most of our deployments have been into the AI and HPC workload space, right? In fact, we just measured this over this last week. We're at 60% of our work of our business today is made up of HPC and AI workloads or usage instead. Last calendar year was a banner year for us in terms of AI specifically. You guys probably are aware there is this kind of hot thing happening in the market right now where everyone's looking to get access to GPUs. And as a result, there's been an emergence of these additional kind of emerging cloud service providers that are specialized service providers offering large amounts of GPUs to AI organizations. We've secured now more than 4. These are 4 public cloud service providers that are almost exclusively focused on AI types of workloads. Lambda, Core 42, CoreWeave, Genesis Cloud. There's actually more that we can't talk about just quite yet. And the interesting thing about all of these cloud service providers is that we're not going in and simply solving, what you would think of as like a fast scratch storage use case. They're looking at us more holistically. There's a lot of capabilities that we also afford service providers that make it extremely unique from a multi-tenancy perspective, from a security perspective, from a quality service perspective, and on and on and on. CoreWeave is a great example of that. We are partnering with them They're a great design partner of ours, where we are now, I don't know if I can say the exact number, but we're stood up in almost 50% of their data centers, standing behind, I don't know how many tens of thousands of GPUs from NVIDIA. And we're doing some very, very cutting edge things, which I'll talk about a little bit later. But we also have enterprise customers. Zoom, if everyone uses Zoom now, you probably have seen all of the additional AI functionality that's rolled into the application these days, right? From silly hand gestures to text to speech to summarizing meeting notes and so forth. Zoom is also using VAST for a lot of their AI ML workloads internally as well. And then Pixar, who's actually been a customer of ours for several years, but only recently allowed us to, I guess they weren't ready to call it a victory, but only recently allowed us to start talking about them publicly. They've been on the forefront in the media entertainment space. I don't know if you guys have seen the last few movies from Pixar, but all those movies were using advanced algorithms to do rendering, right? Rendering of movies like Soul, which would kind of put them on the map using a technique called volumetric rendering. And it's pretty phenomenal, the things they're able to do now. VAST is also underpinning that entire environment at Pixar as well. Now, I wanted to take a quick step back into the time machine and help explain a little bit about where the company, where Renan, our founder, originally had in his mind when he started the company back in 2015. I'm going to tell this through my own personal story. So I met Renan in 2016 in San Jose at a coffee shop where he doesn't drink coffee. And he was explaining to me this radical idea that he had. He had just left his employer, previous employer, and he wanted to start this new company and go build something radically different. These 3 slides are actually slides from his original investor deck that he pitched in 2016. And if you look at it, it's pretty interesting, right? So this idea of building a data center scale computer, right? That could be a thinking machine, right? What is a thinking machine? A thinking machine is something that can process data and output data and use that data to feed back into itself to refine its own understanding of data moving forward. Sounds kind of familiar, right? Remember, this is 2016. AI wasn't really, like, AI existed obviously, but it wasn't trending in the mainstream. And he had a roadmap, right? Because a lot of people ask us, like Keith mentioned earlier, not a lot of storage companies are leading this conversation, but we jokingly say, VAST is not VAST storage, it's VAST data, right? He had a plan and a vision on what he thought he needed to do from a roadmap perspective to realize this vision of a data center scale perpetual thinking machine, right? You can see, I don't know if you can see in the small font, right? The first stage was obviously, you got to develop a storage system. Second one is you got to build data management capabilities. You got to build a transactional storage system. All of these things were things that Renan was thinking about back in 2016. Now, obviously, you can't build all of that in one night, right? Rome wasn't built in a day. But this was the direction and the vision that Renan's had from day one. So what does that look like, right? So from a timeline perspective, like I said, the company was founded in 2015. The product was launched for the first time in 2019. I joined the company February 2020, so it's been just 4 years. I wish I'd started a little bit earlier, but the product was launched at 2019 with shipping customers, and I think the first revenue came in 2020, which was obviously the kind of the genesis to our success. If you fast forward, I've already talked about the success we've had in those first 4 years, but we've been making more and more efforts to kind of proving to the rest of the market that this is the real deal. Like, we've built something that's very, very unique. We were the first, you could call it, enterprise storage system that was certified by NVIDIA, tested by NVIDIA to be SuperPod certified, right? So if those of you don't know what SuperPod is, NVIDIA's DGX SuperPod is their Cadillac. Do people still say Cadillac? Their Rolls Royce, I don't know, whatever analogy you want to use there. But it's the pinnacle of what large-scale AI infrastructure should look like, right? And we're still, to this day, still the only ones using standard enterprise storage protocols like NFS to get there. But if you fast forward to this past summer, we started to unveil some of Renan's vision from 2015, 2016, right? We had this launch event. It's all over YouTube. You can go look it up and watch it. It was very, very well produced by our team. I called this Build Beyond event. And in that event, we started to introduce some new capabilities that we called the VAST database, capabilities like the VAST data space and the data engine. Now, what are all those capabilities and why are we talking about them in the context and why is it relevant in the context of AI? Well, it's pretty simple, right? Because if you think about that thinking machine, all of this is effectively a virtuous circle. It's a loop, right? It's a feedback mechanism that turns this into a perpetual machine. We started off with, we rebranded our kind of core storage product into a brand called, a product name, sorry, called Data Store, right? Data Store is our core, kind of what everyone in the industry from a storage perspective has known about us, which is our ability to provide enterprise NAS, our ability to, file, NFS, SMB, our ability to provide object storage. We wrote our own from the ground up S3 compatible object storage system. But we also built and pioneered new ways of using things like NFS to run at local NVMe speed. So we were kind of the first ones that reinvigorated things like RDMA for NFS, right? We were also the first ones to build effectively a driver that unlocks the ability to use NFS and go hella fast. I'm in California, I'll say hella fast, right? So really, really fast, right? It's speeds necessary to power a lot of these GPU machines. We're also going to talk about block. We have customers using us also for Kubernetes even today as we go. But we introduced concepts like the database, and we'll talk more about in Neil's section why this is so important. If you remember on the investor deck that I showed you from Renan's 2015 slide deck, right? This idea of transactional, transactional data in this integrated system is very important. We're using the database. It's effectively a tabular system that is fully transactional and ACID compliant, but it runs at data lake exabyte scale, right? So think about that for a second, right? Just like in the early days of VAST, where we were breaking trade-offs between performance, scale, and cost, right? We're doing the same thing in the world of structured or semi-structured data in the same way. So imagine now being able to have granular access to exabytes of data, be able to find a needle in a haystack very rapidly. This is the basis for providing a lot of structure to a lot of unstructured data, which is very, 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 very important if you need to do any kind of AI, ML work and deep learning work as well. The next thing we talked about is the data engine, and we'll go into more detail here and give you a good example in the OA section as well. Yeah.
I gotta stop for a second because these are some big claims.
Yeah.
And when I think of these claims, some of the delegates, and Jenny, mind if I call you out?
It's a little late.
Done.
Yes, you're gonna.
I got to give credit because she is helping me to kind of understand where you guys are seeing you're in the market. So compare this, and because I think where we can wrap our heads around is something like a snowflake.
Yeah.
Mm-hmm.
So where is this in the market in comparison to like a snowflake?
So the funny thing is, some of you are in storage field days, I know, right? And we oftentimes show that pyramid, right, in storage. You have that same concept in the world of analytics as well, right? So you think about, you have transactional systems, you have analytical systems, right, and so forth. So the database for us, you mentioned Snowflake. Snowflake is a very popular SaaS-based data warehouse, right? Super easy to use. The types of workloads they go for are interesting. They tend to be, like good performance queries, tend to be not data lake scale, right? So when I think about the difference between like a data warehouse and a data lake, data warehouses tend to be fast, but smaller capacity of data, right? Data set size. Data lakes tend to historically be very, very large, right? A large dumping ground for all of your data. And they end up being a lot slower, right? More batch oriented or just longer running jobs. We think there's a way you can have both. You can have your cake and eat it too. So that when I say, transaction capable, data lake, exabyte scale, that's what I mean. You want to be able to store all your data in a single place, right? That's obvious, right? Like a dumping ground and archive. But you also want to be able to query that arbitrarily and find any piece of data instantly. That's what we're building right here.
So that's what you're building, or that's what
That's
you
what we
built?
built. That's what we built. And we have customers actually using this already. The other interesting thing about this is this is a technology at a foundational level, right? So we've introduced new capabilities. One of the use cases, for example, for the database is something we call the VAST catalog. So there's a self-indexing catalog that we now maintain inside of our product. You can throw hundreds of petabytes of data at our system. We can store it all. We can also automatically catalog that entire namespace for you. And you can ask questions of the catalog now because it's writing on the database. And I can give you an answer. I can find you any file that you created last week that exhibits certain properties, and I can give that answer back to you instantly. And that's integrated fundamentally at the file system level. Now that's one applied use case, but if you now take that idea and open it up to customers, specific applications in their domain, they can get that same benefit and stuff any kind of data they want inside of it. One of the examples would be we have integrations now for this database table format with very, very popular tools in the data preparation, data pipeline stage, like Apache Spark, right? I'm not going to steal all of Niloy's thunder here, but we have integrations there where we can now accelerate a lot of those same tools by using the underlying database format inside of our systems.
So help me understand this from a workflow perspective. I'm dumping a bunch of, let's say they're relatively structured, their image files into a directory. How do I then, go from this being just a file system that's, universally available to something that has a higher level of capability from a database perspective?
Sure. So a great example would be there's two aspects. So you dumped a bunch of images. At a file system level, we automatically catalog. Think about all of the POSIX file system attributes, right? So it's kind of more infrastructure oriented. That's our catalog. We do that automatically. Customers don't have to do anything, right? So if you're looking for files over a certain size, that's an example of what we could do with the catalog. However, that same database functionality can also be used to store custom metadata that the user may want to run. So for example, maybe you want to apply a inferencing engine to analyze it's a bunch of photos of people. You want to understand what is their sentiment, right? Are they happy? Are they sad? Is it a man? Is it a woman, right? You can be able to then run all of those and store that metadata in that same database. So no longer do you have to go and look at a bunch of files to make that determination. That's been pre-computed by whatever algorithm you want.
What's the API? What's the API for something like that? So if I want to do object detection on, a database of thousands of images and stuff like that, I'm going to be generating a lot of data associated with each, with each object. So where's, what kind of a, for a database, is it SQL?
It is. It's exactly SQL compliant.
It's not NoSQL.
It's not NoSQL.
ACID-based.
It's ACID-based, fully transactional. We have many different ways to access this SQL database. We have our own. Yeah.
What do you mean SQL compliant? So it is SQL or?
It's SQL. It's a SQL-based. You could think of it as a giant table, right? Like tens of thousands of columns and billions of rows, right?
So the curse of dimensionality.
I'm sorry?
So the curse of dimensionality.
Yeah.
So it's not what you'd call a vector database?
Vector database is a semantic layer that can be run on top of lots of different data stores, right? That's something we don't have shipping today, but something that we are working on.
But you also have columnar lookups?
Yes.
Yeah, on top of that.
That's right.
But the data isn't persisted like a column store, or it is?
It's internal. It's stored in a format that is our own, in our own tabular format, but it is columnar based.
Okay.
Yes.
Okay.
And events.
So events, so the data engine is the last piece, right? So kind of to tie it back to your question, the data engine is something that we are starting to preview right now. And you can think about this as an inventing engine. So when you upload an image, imagine this, right? When you upload an image, you want to be able to create, have a trigger that then runs an inferencing model against it, right? And then store the output of that inferencing result into the database, for example.
So what would be really cool? So I have VAST, I have my file system. I store a file. A event or a trigger
Trigger.
is created that runs on a bus that Lambda picks up. Lambda picks it up and says, "Oh, there's a new image file here. Let me go run inference against it, and now let me add the metadata to the database as stored."
Bingo.
That's where we're headed.
It's a perfect example of how the VAST Data Platform is
So
where we're headed.
So where is that server functionality, object detection, all that stuff running? I mean, it's not running on a vast solution, is it?
We are actually going to provide a framework for customers to run their own code, right? So imagine like a function that a customer can load onto our system into the data engine, where a trigger will be created by our file system that will basically point to call a function that the customer defines. We're not shipping those functions ourselves. So we're not in the business of writing the inference model.
So you're going to have GPUs on your storage?
If the customer ends up running inferencing jobs, it will have to kick out somewhere. Yeah. We're not writing the code, right, for the inferencing job.
understand, but
yeah.
even providing the infrastructure is a bit of a stretch for a storage device.
We're not a storage device company anymore. We're building a platform, right? I think that's the biggest takeaway here is, like I showed earlier about Renan's vision, we're not stopping. Storage was the foundational level that is necessary to do a lot of this other stuff, right? We're not reinventing the wheel. So I'll give you a concrete example for the data engine. We're starting with Kafka, right? Very, very popular eventing framework. We're starting there, right? We're trying not to reinvent the wheel where it's absolutely not necessary.
So if I'm in something that's friendly to kind of this cloud native infrastructure, let's say I'm running this, let's say that I'm a advanced thinking managed service provider and I want to provide this as a service. I can now I can use the VAST Data Platform as the repository to dump the actual data in, but by extension, I'm getting this database functionality.
Yep.
And now I can provide this security camera, whether it's retail, security, whatever the case. I can use computer vision instances in whether it's C3, et cetera, to now extend the capability without me needing to go back and create my own data platform to do this, or being locked into Snowflake or one of the other platforms.
That's right. So I think you just hit on something very important. I showed earlier that we've had kind of a banner year with cloud service providers. What you just said is the reason why we're having so much success, right? These service providers, I'm not talking about AWS, right, who has their own platforms and such, but these other competing service providers need something more comprehensive than just GPUs as a service, right? It's not enough, right? You have to think about this more holistically from a pipeline.
Yeah, if I have to compete against S3, which gives me all these native capabilities.
It's not just S3, right? Now you have to also compete against, they all have some sort of analytics engine, right? As well. And it goes on and on. They have a trigger-based eventing engine too, right? There's all these different capabilities. And if you like that experience in the public cloud, think about as an enterprise, you don't have anything equivalent to that in your data center today either, right? So that's the direction of where we're headed. Okay,
Where are you? I had a question here. This is
yeah. Hey, Sumit.
Hi. So where are you running your Spark workloads? Is it running within the compute layer within VAST, or is Spark running outside? Because Spark itself is a compute engine, right?
Yep. So yeah, so right now we have a project where we're actually integrating Spark into our compute nodes itself. So you'll have that integrated in. Got
it. And what about the Kafka side of things? Kafka is again a separate cluster or a separate.
So this is a great tee up into this very next slide, because this is kind of a reminder of how our architecture works, right? So a lot of those compute engines you just talked about, so like Spark and Kafka, they can be containerized. And if you guys have been following VAST for quite some time, you'll understand that all of our software is 100% containerized as well. And we deploy containers into different dedicated machines, right? For those of you who haven't been following us, this underpins everything I just showed on the previous slide in terms of capabilities that we're rolling out into the market, right? The disaggregated shared everything architecture, going back to my first meeting with Renan, not as cliche as scribbling on a napkin, but he described this concept to me. It didn't have a marketing name at the time. but you know, I have a computer science background, so I knew like if this could actually be solved, it actually breaks a lot of computer architecture problems, right, that have plagued storage systems for a long time. This is, in my opinion, personally, this is our biggest differentiator, even though it's deep, deep, deep tech, right? This is the core of what allows us to do everything that we've just talked about on the previous slide, right? Disaggregated shared everything in a nutshell is effectively the ability to separate the logic or the processing, you know, think about like the file server, if you will. You're disaggregating that from every single disk drive in your entire cluster, right? Versus shared nothing systems where you typically deploy a CPU with some number of fixed disks to it, and then you stamp that out. This architecture doesn't have that tight coupling. Every single CPU can see can access and feels like every single disk in the entire cluster is locally attached. And it happens to go through a very fast fabric in this case. It means we get better scale. We don't have any east-west traffic, right? It's way more reliable because when a node or an instance or a container fails, there's no ownership of having to rebuild the disks locally attached because there's no such thing as locally attached disks in this example, right? And there's a whole bunch of other benefits as well.
So
Yep.
this is just feeling really familiar. Is this the Extreme IO stuff? This just seems very familiar and very related to that.
Extreme IO, I've never heard of them before.
Is it kind of a
No.
pull through?
No, Extreme IO was Block, I believe. So
Okay, so you
that's
guys
different.
extended, and you learn stuff from Ceph, so that's great.
If you looked at, yeah, it's not a surprise. Renan also came from Extreme IO, so there is some heritage there. But I think architecturally it is a pretty big
So you're
departure.
denying your heritage right here.
I'm denying my heritage. I don't know. No, I don't think so. We embrace our heritage, but we look toward the future. So
Renan resurveyed the market to validate what the needs were, right? So it wasn't just what had been done in the past. It was you're reevaluating the market and understanding what the present needs of the customers were and what was possible with technology that wasn't available 10 years ago, but was only available a few years back.
I think the biggest difference, and Renan tells a story very well, right, where he traveled around the world on his former employer's dime at the time, and just interviewed a bunch of customers. And basically, the first thing they said was, "We don't need more performance. We need it more economically." Right? Flash is fast enough. We need something more affordable. And so there's been a lot of focus on everything that we do, from how we designed the system to architected the software architecture, was on, could we leverage this to build something cheaper, right?
Some of us kind of like, I mean, I kind of like that story
Yeah.
better than not giving a nod, unless you just can't give a nod to it. But like, some of us liked Extreme IO, and we liked the whole idea of it, and we
Did really well.
right? It was great, and so to see it being, you know, the
I just don't want to get sued. That's all. So
that's what I was asking.
kidding. No.
But
I'm
like,
kidding.
like to see the seeds of it, you know, and those ideas coming back out again are great.
I think Renan would also be the first to admit that he had a lot of these ideas, obviously, at his previous employer. But when you have a product that becomes mature and has a large install base and billions of dollars sold, you're not going to turn the entire architecture on a dime, right? So
And it would have been possible where he was.
it's hard. Yeah,
No, not hard, impossible.
possible. Sure. Okay. All right.